Hi everyone. In this video, my goal is to go over assignment 5 for the molecule project, which is to comment on an incorrect separation scheme and then draw a correct separation scheme. So that's basically what I'm going to do. So there's a couple things I've already done. First of all, I've opened my previous work that I used before in Chem Sketch. I have also downloaded my mechanism, or excuse me, my incorrect separation scheme, which is a PDF available on Blackboard. So you can just download that and put it on your desktop. As usual, these are going to be instructions for a PC. A Mac probably will do the same thing. I just don't exactly know how to do that because I'm a PC user. So the other thing I have done is I've opened my project that you've seen on the previous two videos. If you haven't seen the previous two videos for the first two assignments or the second two assignments, feel free to watch those. Those are also available on YouTube. So the first thing I want to do is the incorrect separation scheme. Now in this part, basically what I want to do is I want to get the incorrect separation scheme into Word and then comment on the issues with the incorrect separation scheme. Now in this video, I'm not going to spend a tremendous amount of time talking about the acid-base reactions. I may talk about them a little bit in the correct separation scheme part, but I'm not going to spend a tremendous amount of time talking about that. In the acid-base extraction video for experiment 4 that I did at this time last week, or in the review for practice quiz 2, which I did this week, this concept is talked about quite extensively in those two videos. However, here I'm going to focus more on actually fixing the separation schemes than actually talking about the theory. If you'd like more details on the theory, you could watch those videos. You can come see us at office hours or go see a TA at office hours, and we'd be happy to help you out with that. So first thing I need to do is I need to get my incorrect separation scheme into here. Well, what I did was I downloaded my incorrect separation scheme as a PDF, and then I opened it with Adobe Acrobat Reader, which is a commonly available tool that you can download for free. And then what I want to do is I want to go to Edit, Take Snapshot, and I want to highlight my entire separation scheme in the PDF, and it essentially takes a picture of it. So I just took a picture of this. Alternatively, if you really had to, you could take a picture of it with it on your phone and then import that picture into Word. It won't look quite as good if you do that. Not that it looks great here, but you can see that I have added now the incorrect separation scheme. So when I take a snapshot of it, in Acrobat, it basically copies it to my clipboard, and then I hit Control V to paste it here, or I could just hit paste. All right, I don't need two of them, so I'm going to delete one, but that is basically that. Now, after you've pasted in your incorrect separation scheme, what I suggest you do is you label the steps. So to do that, you want to go to Insert, Text Box, and you want to hit this Draw Text Box option, and I'm going to put one right there, and I'm going to call this step 1. All right, so I've labeled this as step 1. If that's not too obvious, you might want to make that bold so that it's a little more clear. You also may want to center it so it looks a little nicer, like that. So I labeled that as step 1. You can leave the line or not leave the line. I don't really like the line, so I'm going to go to Format, I'm going to go to Shape Outline, and I'm going to push No Out. So that's step 1. Now I can hit Control C, Control V, and it can make step 1 again, but this time of course I don't want to call this also step 1, so I want to call this step 2, and then Control C, Control, whoops, I hit the wrong thing. I didn't want to Control C, Control V there. I just wanted to simply Control V again. No, now I've copied the wrong thing. I apologize. So I'm going to have to grab this again, Control C, Control V, and now I've got this, and I can call this step 3. So now I've labeled the 3 steps so that I can clearly talk about each step. And what I want to do is go through my 3 steps, and I want to look at whether or not they are correct. And in order to do that, what I'm going to do is I'm going to come down here below this. I'm going to hit Enter, and I'm going to go over here, and I'm going to set the font to something reasonable, like 12, and I'm going to type in step 1. Now I want to comment on what's going on in step 1. So let's take a look. In step 1, we add ether. I have 2 organic molecules. Both of these molecules are soluble in ether. So that's okay. Then I add 6 molar NaOH. What is 6 molar NaOH going to do? Well, 6 molar NaOH is going to deprotonate the carboxylic acid of my molecule. I should remind you, this is my molecule. This is the molecule I'm trying to separate it from, which is benzocaine, which you're using in the lab. So this molecule is going to react with the OH, and you're going to make the carboxylate, the sodium carboxylate of this carboxylic acid. But what actually happened? Well, what actually happened is the carboxylic acid didn't react at all, and the amine, which is an organic base, meaning that it accepts protons, lost a proton to the base. Now, it is not impossible to take off this proton, but it's not going to happen with sodium hydroxide. You'd have to use a very, very strong base. So this is not a strong enough base, so we're not going to be able to take off this proton. So in this case, what is the problem is the 6 molar NaOH would deprotonate the carboxylic acid, drawing it into the aqueous layer. The amine will not react with sodium hydroxide. So those are the 2 problems there. So the problem is, first of all, I have the wrong molecule reacting. This acidic proton is going to react with NaOH to make the carboxylate, which is minus and will be in the aqueous layer because it's ionic. And what will not react is this molecule will not lose a proton. So I've put that here. All right. Now what I suggest you do is consider the steps independent of each other. So let's just look at the steps completely independent of each other. So in the next step, we have this molecule reacting with lithium aluminum hydride. Lithium aluminum hydride is a reducing agent. Said another way, it's a source of H-. Lithium aluminum hydride is not going to necessarily add here, although it's probably not impossible. Okay, so this is kind of a weird situation where the reactivity of this is really out there and not something you would ever have. Okay, you would never have this molecule to react with this molecule, and if you did, it would probably be a pretty violent reaction because this is positively charged and this is a source of H-, so it could theoretically add there. However, this reaction is generally speaking unlikely to occur, right? Because you're practically not going to be able to do it. So here I would say lithium aluminum hydride luckily Word knows how to spell better than I do, is a reducing agent and is not used in acid/base extractions. So I'm just going to say that lithium aluminum hydride has no place here. If you see other reagents like sodium borohydride, another reducing agent, or any other reagent that doesn't really belong, I think you can use that as your logic for how, for the reason that it's not present. We're not doing reactions here, we're doing separations. The common things that you can have are acids and bases. Now, if you have NaOH or sodium bicarbonate, that's just a different base. That's totally fine. Or if you have HCl or HBr, that's just a different acid, and that's probably totally fine as well. If you see weird things like lithium aluminum hydride, or you saw a Grignard reagent, or any of this other kind of stuff, I would just say that has no place in a separation scheme and in acid-base extractions. That's also a good hint for the quiz. If you see reagents you've never seen before, you probably don't need them, and they probably don't have any place there. All right, let's look at the last step. Let's look at step 3. In step 3, we have this molecule dissolved in ether, and we evaporate the ether. and we get our molecule back and our ether. Well, although this molecule would never be still in the ether if you added 6 molar sodium hydroxide, let's ignore that because it gets too complex if we have to consider every previous step on top of it. So let's just look at step 3 as its own thing. Yes, if you have this molecule dissolved in ether, it will form as a solid. One minor thing is you would probably have trace water here, so you may want to comment on that because you did a liquid-liquid extraction. So probably you need to use a drying agent first. So what I'm going to say is step 3. This step is correct. However, it may be necessary to dry, again, my spelling, it may be necessary to dry the ether layer before evaporating the ether. All right, so a combination of my spelling and my typing, but you can easily just fix it like that. So this is basically how I look at the incorrect separation scheme. Now remember, a few things that are very important here that we need to be aware of, okay? First, I'm considering each step independent of each other. If I see reagents that are not familiar, it is good enough to write that they should not be used in an acid-base extraction. You don't need to explain whether this theoretical weird reaction could possibly occur, because it is possible that this reaction could occur, but it's not practical, and how you would make this might deactivate this, and all this kind of stuff that we don't need to consider here. But we can basically just say this has no business here. In the case where something fundamentally works, even though the previous step is wrong, just consider this step independent of each other. Now you may be saying, well, what about this necessary to dry the ether layer bit? That's considering the previous step where you had water extraction with ether. So, it's basically, we're not going to be super picky about this, but you remember that before you evaporated the ether to get the biphenyl, out in both of the extractions you may have done already. In those cases, we did dry the organic layer before we evaporated the ether. So if you want to say that, that's a good idea. But it's probably not totally necessary. So I hope this gives you some idea of one way in which an incorrect separation scheme can be considered as you go through each step and you decide what is wrong with it. Now, we need to write the correct separation scheme. So I'm going to make my font bigger again. And go ahead and center that. Now with the correct separation scheme, I find that it's easier to write the correct separation scheme on using this program, okay, using ChemSketch. So the very first thing I want to do is I want to grab my molecule. This is my molecule. So I just want to go ahead and copy that or hit Control C, and then I want to go to File, New, so I have a new place to put it, and I hit, whoops, I didn't mean to do that. So I'm just going to hit Control Z, and then I'm going to hit Control V so I can paste my molecule. So this is my molecule. I now need to draw the benzocaine that I was told I have to separate my molecule from. So I'm going to go ahead and draw that, starting with the ring. And over here, I want to put a carbon. And then, sorry, I didn't want to do that. I want to put an oxygen here. Make that a double bond. Put an oxygen here. And then put an ethyl group there. And then finally, I want to put an NH2 down here. So that is benzocaine, and somehow I deleted a carbon, so I'm going to redo that like that. So now I have an ethyl group attached to an ester, and I have an NH2 over here. I'm going to click this and try to move this thing out of the way of the other one. I think I'm good enough. Whoops. And I can get it a little bit out of the way. And then if you recall, I'm going to highlight this, and I'm going to hit this and clean it up a little bit. So now it looks a little bit better. All right, so now I have my two molecules. And in this case, as may be likely in it is as is possible, I guess I should say, in your case, there are two ways we can go after this. So we have a carboxylic acid group and we have an amine. So we could use a base to get rid of the carboxylic acid, or we could use an acid to get rid of the amine. The choice is really yours. However, in my case, what I'm going to do is use a base. So just like you did in the lab, when you essentially had these two molecules, you had a different carboxylic acid than the one I have, but you had benzocaine, and we have a carboxylic acid. So what I want to do is I want to click on draw, and I want to draw some lines. So the first thing I want to do is draw a line down, and then a line across. I'm trying to make it nice and straight, and then I want to move it. So I'm going to grab this, and I'm going to move it so that it looks roughly centered. And then I'm just going to grab this. I'm going to hit Control C, Control V. I'm going to put one there, Control V again, paste again, and I'm going to put one there. Now what I'm going to do is I'm going to highlight this whole thing, this separation. I'm going to hit Control C, Control V, and I'm just going to put one down there out of the way so that way if I need another bracket, I don't have to draw it again. All right. Now I need to go ahead and put some text in here. To put text into ChemSketch, I go ahead and click on this, and then I'm just going to click right there. And in my case, I'm going to add ether and 5% NaHCO3. To subscript this 3, I simply highlight it and click this S- thing, and I get my subscript. So now I want to add ether and 5% sodium hydroxide. Now I'm going to have two layers. I'm going to have an aqueous layer here, which I want to just move this a bit so it's right there. And I'm going to have an organic or an ether layer. I'm going to label it as organic, and I'm going to put it right there. So now I have my aqueous and my organic layers. Well, what's going to happen? This sodium bicarbonate is going to remove a proton from this molecule because this is a base and this carboxylic acid is an acid. When I remove this proton, this molecule is going to be ionic, and when it's ionic, it's drawn into the aqueous layer. So what I want to do is go back over to structure. I want to grab my molecule, hit Control C, Control V, and I want to paste it here. But here, instead of this OH, I want to add a sodium. To do that, I first want to make my oxygen negative. So to do that, I click down here, and this may have defaulted to positive, or it could be on negative. Just click on it, and then I want to make that negative. Then I want to add an Na plus next to it, something like that. So that is now my ionic compound in the aqueous layer. What else is going to be in the aqueous layer? Well, if I go over to draw, I'm going to get CO2, which is going to be a gas bubbling out. Since this is a gas, it doesn't really matter which layer you put it in. We generally put it in the aqueous layer, but carbon dioxide will bubble out of the solution. So I'm just going to write it like that, CO2 gas. Now what's going to happen over here? Well, over here, when I want to go back over to structure, I want to grab this one. This molecule, nothing's going to happen to it. So I hit Control C, Control V, and I just put it there. What else do I have in solution? If I go back over to draw and I hit on here, I have ether and trace H2O. Remember that whenever you do a liquid-liquid extraction, you're going to end up with traces of water in your ether layer. All right, so now I've gotten my molecules into two separate layers. Well, how do I get this one back? Well, now I'm going to drain off this aqueous layer, and I have the sodium salt of the carboxylic acid, so I want to turn this back into the carboxylic acid by adding HCl. So you'll remember that I put this down here so that I could just grab it whenever I need it. So I'm going to go over here, I'm going to grab it, Control C, Control V, copy paste, and I'm going to put my lines over here. Now what do I want to do? I want to add 6 molar. I'm just going to put 6.0 molar so it looks more professional, HCl. It doesn't really matter how precise the concentration is here or how accurate it is. Okay, so I'm just going to put 6 molar HCl. I'm going to again end up with 2 layers. This time I'm going to put the layer over here as a solid because it's going to be a precipitate. And I'm not getting them in the right place, so I'm just drawing them and then moving them. And then over here, I'm going to have aqueous. So on the other side, I'm going to have aqueous. And again, I'm just drawing them wherever and then moving them where I need them because I'm not having good luck clicking exactly where I want it to begin with. What am I going to have in the solid? Well, the solid is going to be my original molecule. Lucky for me, I already drew it. So Control C, Control V, and I'm going to put my molecule back in like so. In my aqueous layer, I'm going to have NaCl, which is the aqueous solution. Now, I've isolated one of my molecules. I've isolated my carboxylic acid. Now I need to isolate my amine. Now you could add a base and then precipitate, or excuse me, add an acid, make the sodium, add an acid and make the hydrochloride salt of this base and then precipitate it. Or you could evaporate it. I'm going to choose the evaporation path. I think neither is right, but I'm going to choose the evaporation path. If neither is right, neither is wrong. So I just want to get this again, Control C, Control V, and I'm going to put it here. And I'm going to add, in this case, anhydrous Na2SO4. Now, you may say add saturated salt water first, and that wouldn't be wrong, but to save ourselves a step, because it's kind of a pain to write this, I'm going to go ahead and just directly add the anhydrous sodium sulfate, which we do sometimes. What I'm going to end up with is a solid. I already have solid, so I'm going to do Control C, Control V. I'm going to put it here, and I'm going to end up with an organic, Control C, Control V, and I'm going to put that there. So I have a solid and an organic. The solid is going to be, whoops, I was hoping I could get that. If I do Control C, Control V, I'm just going to type it in so I don't have to worry about how to write the dot. I'm going to type in hydrated Na2SO4. So that's going to be my solid. My organic is going to be what I originally had. So I'm going to go ahead and grab this and grab these two things and do Control C, Control V. I'm going to put these down here, and this time I want to get rid of this trace H2O. Finally, this is the last time I need this bracket, so I'm just going to go ahead and click on this and grab this bracket one last time, but this time instead of copying and pasting, I'm just going to move it because it's the last time I need it. I'm going to go ahead and type in evaporate ether. And when I do that, I'm going to end up with two different things. In this case, I'm going to end up with a gas and a, solid. Not a GS, just an S. A gas and a solid. So I'm going to move this to where it fits. I'm going to move this to where it fits. My ether, which is just as easy to type it as copy and paste. So I'm just going to type in ether again in my solid, or in my gas, excuse me, because it's going to evaporate off. And for this molecule, it's much easier just to copy and paste than to redraw it. So Control C, Control V, and I put this molecule. So I now have a correct separation scheme. I can simply copy the entire separation scheme and copy and come over to Microsoft Word. I've already made my title, hit Control V, and my correct separation scheme is entered. I found that it was much easier to write the separation scheme with ChemSketch than it was to write it with in Microsoft Word to try to draw these lines. The other thing is I'm noticing that I missed a couple things here, so I'm going to come back over here, and it looks like they're there, I just didn't grab them. So I'm going to try like that. I'm going to try one more time. Copy. and then come back over here, Control V, and now I have organic. This one's still not showing up, so let's see one more time if I can do edit, select all, and if I do that, now I do copy, and I do paste over here. Now they're all showing up. So you may have to play around a little bit to make sure that nothing is missing. I had to do select all, so maybe that would be a good recommendation for you. But I was eventually able to get all of my correct separation scheme in here. I understand that playing with this software is a little bit of a pain in the neck. I find it to be a pain in the neck as well. However, it's good practice, right? When you do it the first time, it takes a long time, but as you do it more and more, it gets easier and easier, and making figures and things like this is something that scientists do a lot. So even if they're not chemistry figures, if this is chemistry is not your thing, and you're interested in something else, you may be manipulating pictures and figures and things in software, and this is simply good practice. So these are my tips for you for how to do the incorrect separation scheme and how to do the correct separation scheme. I hope you found this information useful. Thanks for watching.